Okay. Brilliant. Yeah, great. I think we'll get going. Thanks everyone for coming along. Asaf needs no specific introduction today. I think he was ably outlined the work he does on people and nature, especially in urban environments, in his previous seminar. But Asaf is a man of many talents and also has done a huge amount of work in the broader landscape, especially human-dominated landscapes, but the broader landscapes beyond cities, using a whole range of really cool techniques and answering some really important and interesting questions. So thanks, Asaf, for making time to speak to us once again. And over to you.
I promise this is the last time, yes? No worries. Yes, it's really, again, a pleasure being here this morning. And I think that's the nice thing about sabbatical. You take a moment to take a perspective and look kind of what have you done? How did this work? And making this presentation, you know, make you think a little bit of the process and what I've achieved, where we're going further and looking back into the future. Starting with the background, as obvious, we know that fragmentation, habitat loss is the key driver of biodiversity loss. And today, from 50 to 70% of Earth's surface already modified human, and this is mostly for agriculture areas. Skip this, I'm sure everybody knows that. And this impact is even becoming more aggravated as agriculture is becoming more intensive. So the whole problem with agricultural intensification. And what do we do to solve this problem, to mitigate this problem? We declare these things you see here. This is one of the first protected areas that declared in Israel. It's called En Gedi, highly recommended. It's in the middle of the desert. If you ever come to Israel, one of the cool hotspots to visit. So we declare protected areas, separate basically nature from us, from humans. And you are doing quite well. So if you probably hear in this group, you know quite a lot, we're doing quite well, and there's more and more protected areas declared, the terrestrial and marine. But unfortunately, in terms of biodiversity, it doesn't provide the full answer. Biodiversity is still going down, and there are various reasons for that. And this is an analysis we did for England a few years ago during my postdoc. So first of all, protected areas are still small, relatively small. They cover small area in England, 6.37%, and it actually didn't change for about 15 years. So we repeated the gap analysis here and found it didn't really change. In the world, they cover about 16%, almost 70%, which is still relatively small from all terrestrial land. They're often located in the areas people don't want, to the remote areas people don't really care about, and not in the areas they should be located to protect biodiversity. And they're strongly affected by what happened around those small protected areas. And there are lots of other reasons that they brought ecology to say, we need to scale out from protected areas. We need to do something different. We need to go out for larger scale, for landscape scale, large scale conservation, multifactorial landscape, ecosystem. There's a lot of different terms for this, basically scaling out from just looking at protected areas. And this idea is not very new. Now, I learned that recently when I talked to my new colleague, my faculty, Shira Wilkoff, who is a historian, and she showed me that there is a report written by planners, not by ecologists, to the IUCN in the 1950s. Look at the title, Landscape Planning, a Policy for Overcrowded World, 1950, yes? Before the Great Acceleration, before it all started, all of this thought about landscape conservation protection, like large-scale conservation, but they were completely rejected by the IUCN. So nobody did anything with this report and didn't accept. They fired them eventually and moved to iconic species, protected areas, etc. So it started way ago. So what's the whole idea of this multifunctional landscape or landscape scale, large-scale conservation is to complement the effort of protected areas by dividing landscape that provide environmental, social, and economic benefits, kind of balancing between this in different functions. And in my postdoc, which I did with Bob Smith and Zoe Davis at the University of Kent, we looked at these initiatives. So England is really impressive in the level of different initiatives we have. So all these different colors on the map. The dark green is the protected areas, but all the other colors are areas that are somehow protected by different type of large-scale conservation initiatives. So this is quite nice on one hand, but when we dip into the data, deep in what really happened in brown, we found that it's actually an unrealized potential. There's a lot of polygon maps on the map, but almost nothing is really happening on the ground. So basically, they fail to balance between human needs and biodiversity conservation. And I'd like to take an example actually from the other side of the canal, from France. This is the Loire Valley, the video here. This is the Loire Valley, and this is the network of protected areas in Europe. Natura 2000, 18% of the land in Europe, if you know Europe is pretty complicated, are protected. And look, this is the Network of Habitat Directive. These are the protected areas. Yes, Natural 2000, if you heard about this, and if you can see, these are protected, again, areas. When you take off the grid, you see what you see behind this grid, 1, 2, 3. Intensive agriculture, right? So the network of protected areas in Europe is built strongly or quite a lot by agricultural land, intensive agricultural land. So what Europeans are doing, they're investing quite a lot of money. 40% of the European budget, at least between 2014 and 2020, was dedicated for subsidies for farmers to kind of do more environmental agriculture, improve the quality of the landscape, ecological quality, environmental quality, etc., etc. And yes, it's working. Yes, it's working. And it has a positive, when you compare area under policy and not under policy, it's working. It has a positive biodiversity impact, but it's not so big. And that's on the other part of the postdoc I didn't present today. It's not so useful. It's a little bit better. Now, what we did learn from years of this kind of policy in Europe, few very important key messages. And I think I actually really like those messages. First of all, the success of these projects or this scheme works much better when you focus on areas which are ecologically important. If you just put the policy all around, it's not so important. But you focus on a specific area, it's actually working pretty well. When you work with the landowner or farmers, you talk to them, you don't put something on them, just negotiate with them. And when you actually adapt the practices to the given specific area. This kind of, if you look through the literature, the European program, these are the key 3 messages that always works in conservation of multifunctional of agricultural landscape. The problem is that not too much knowledge, we don't have too much knowledge from the Mediterranean region where I live, Israel. And when I came back to Israel, so I'm really believing in bottom-up kind of applied research. So the first thing I did with those ideas in mind, I went to my friends in Nature and Park Authority and asked them, okay, what's on your agenda? What's the problem you are really concerned about? What are you going to study? And they came up with 2 topics. One of them is the ecological corridor, and specifically Harod Valley, which I'm going to talk about most of my talk. But before they were really concerned about the abandonment of traditional agriculture like olive orchards. So I will start with this thing, and then I'll move to the Harod Valley. These are the Harod Valley here, and the area we studied in the Lower Galilee with the olives is here. So starting with them and connecting it with the theory. So the question I was asking in this project, we were asking is actually understanding how to plan and manage sustainable agriculture landscape that balance between ecological, social, and economic functions. And we choose to focus on olive orchards. Olive orchards are really important, iconic crop in the Mediterranean region. Been there like that for over millennia. In Israel, it's covered about 34,000 hectares. Mostly it's rain-fed extension and traditional olive orchard like the one you see here in the picture. Okay. In Israel and across the Mediterranean basin, the olive production is becoming more and more intensified, and this actually provides a unique opportunity to study the impact of intensification, but also identify solutions for options that are maximize ecological and social values in this iconic crop. What do I mean? So these are the traditional groups you see here, all trees relatively, kind of weeds around them, and mostly dealt with the weeds that dealt with grazing. This is the expensive, mostly Arabic in Israel. Arabic minority are cultivating them many times on terraces. Today, because they're not that profitable, farmers are using plowing and herbicides to get rid of the weeds. And this is a more intensive organic, as you see here. Here, there won't be any herbicide or any type of pesticide used, and they will use mowing, and they'll do the mowing actually late in the year. It's actually much better ecologically. We'll see that. And these 2 things are intensive agriculture. You see here, and the really bad one, somebody termed it, I think they're right, the silent spring of olive orchard. This is the super intensive. These are very dwarf trees, and the tractor goes looks like vineyard, intensive vineyard, and really you sample bird there. 10 minutes, 20 minutes, you hear nothing. Really no bird, like really silent. If you want to go find a silent place, it's a good place to look for silence. This is the kind of controlled natural landscape, park forest of oak trees. So this was the control site. This is our study site. A lot of I'm living here actually, just by this reserve. This is Haifa, Tiberia, Nadarat, so very famous area historically in the Bible. And these are our study sites. All across the Lower Galilee. We had 38 olive groves, 12 ecological control sites, and we did an ecological survey of birds, as I already said before, plants, we did transects. We did social survey, again, looking at the social aspect, and here we used 30 images of different growths, traditional, extensive, organic, intensive, and super intensive, both eyesight and aerial perspective, and we ask people to what extent they like the landscape, what they want to spend time in the landscape, do they feel connected to the landscape, kind of self-connection. We have to rate it between 1 and 5. And we did an economic survey, which we took information about the yield, the inputs, revenue, and of course, the profit. So this is Raz, for God's sake, master student who led this huge and very impressive project. So a bit for the results. The color is going to go with us throughout this part of the presentation. So the brown is the control, traditional, extensive, organic, intensive, and super intensive. Then you start seeing the trend. This is in bird richness. This is the trend you see in bird abundance, so kind of climb towards what we expect, toward the super intensive, much stronger decline in plant richness, where the extensive and organic are in the middle. And when you look at the plant cover, similar trend again, decline, and the organic is really high. So the organic was kind of in between and sometimes higher than the extensive. I want to say also that we find similar results for community composition, and it's important to note that in the traditional, those ones, the red ones, we also find some endangered rare species, plant species. That's the only site to find some endangered rare plant species. And when we look at the social results, we find again a similar pattern. Differences are smaller, but are significant, going from the traditional all the way to the intensive, super intensive, with one small change, the organic. Yes, the organic was actually better. People really like the green cover of the organic rows, and it got, in all of them, the got score higher than the extensive and higher than the super intensive. So the organic is appearing as an interesting opportunity. And what was really surprising was the result of that economy. Normally, when you talk about agroecological practices, we expect that the yield will go down. Organic, we expect the yield will go down, and this is not the case, at least for olives. So yield is very, very similar to the super intensive and intensive. They were grouped together here for statistical reasons. And revenue is similar, and profit was actually even higher. So the higher profit goes for the organic. This is because of the high price of the organic product, at least at this stage in Israel. So what do we actually see? This study showed that there is a trade-off, as we expected to see, between ecological in green, economic in blue, and yellow with the social stuff. And you can see that traditional is maximizing the blue and the ecological and social, while the intensive and super intensive maximize the economic. But look at the organic. Some kind looks like a nice opportunity. It actually is a nice opportunity. It's relatively high ecological and social value, nice yield and profit, so can provide useful food and similar to growth. And basically, what we need to do here is something really simple. We need to encourage farmers to move for organic farming. If you just encourage them, we can increase, not infect the yield, increase the profit, and increase our ecological and social value. On the other hand, we have the extensive growth. These are mostly Arabic farmers in Israel, medium social ecological value, low economic value. So most of the times they lose, okay? They'll really almost lose. They're doing it for cultural reasons, okay? For cultural reasons, they want to keep their crop, their orchard or grove cultivated. They don't want to lose the land, so they cultivate them, but they don't know how to do it because it's been centuries, years since they do it. So they're doing it with tractors and with pesticides and herbicides, etc. And basically, they're killing the biodiversity there. So this is a great lose-lose opportunity, which can be easily turned to win-win with a bit of subsidies from the government to encourage those farmers to take a better, more pro-environmental approach. Anyway, they're not earning too much from this land. And the last one is the traditional one. We provide high ecological values, similar to semi-natural habitat. This is a great opportunity for conservation. Also need to protect the traditional practices, that if we keep those traditional practices, we also keep some of the agriculture-oriented species that are disappearing due to intensification. These are three different opportunities within this realm of olive orchards. This is the first part of the research, talking about this, what happened in the olives, and very important crop, actually the biggest orchards in Israel. And the second one was all the topic of ecological corridors, and specifically in the Harod Valley. So this is the place we're going to talk about. I'm now standing on a mountain. So if I'm standing here, I'm in front of the mountain, on the mountain called Gilboa. I'm looking toward the north. There is more nature reserve around here in the middle. There is a huge intensive agriculture area with fish ponds, vegetable, wheat, etc., etc. And because it's separating two big chunks of natural areas, this is the valley. We're here. separating the two. Because of separating the two, it's been declared and was recognized as an ecological corridor, very important ecological corridor, north-south, but also east-west, in a little stream that passed in the middle of this valley. Now, there's quite a lot of work that was invested in this and put a lot of different types of ecological survey, not scientific, but by experts, and planners work on this project and came up with two ways of making this area a corridor. One way is looking at the whole landscape as corridor, implementing agro-environmental practices throughout, like everything, like the organic I told you about, a field margin we'll talk about later, but like all landscape, or actually focus on few very narrow streams and restored the habitat along those streams. So these are the streams we're talking about here, and looking at all those areas. When I heard this, that's just the beginning when I came to it, I was really excited because this really fits to something I was working on in my postdoc, which is the sparing-sharing debate, one of the big debates in conservation. And I'll take you through just a little bit quickly. I feel like a situation we have natural habitats, areas of, let's say, organic with supposedly low-yield farmland and high-yield farmland. We need to increase food. We have two ways, or potentially two extreme ways of doing it. One way is to increase the high-yield farming based on the area that was low-yield farm, like the more multifunctional landscapes, reduce it, keep the protected areas the way they are, and this we call it land sparing. We spare the land, we separate intensification, agriculture from protection. The other way of doing it is to do the land sharing, okay, but actually increasing the land under high-yield farming, increasing the protected areas, and having a lot of area which is kind of mixed deal, again, organic and all these kind of practices. So there is this the big debate going on in conservation, in urban ecology. There's Rich and Brenda Lynn introduced the idea, and also in agroecology quite a lot. And you look at it from these kind of images, look at one big corridor. Remember, we're talking all the time about the idea of corridors, one big corridor throughout the landscape, or just putting many field margin all around. And that's what we're studying in this topic. It's important to say that all the sparing sharing look at yield or biomass and rarely look at economic data. They ignore ecosystem services, and they were rarely tested for Mediterranean area. So that was the objective of the PhD of Hila. But I was really excited about this sparing sharing. It fits. I like it when the applied question, it actually goes along with theoretical question. But then I remember the key lessons from the European program. You have to focus, you're already working on an area which is important, talk to the farmers, decide which kind of practices you want to do. So just before I'm going to talk about the shared spraying, I want to tell you about another research that led by Tef Seker, which actually the first research started in Israel, again, social research, trying to understand which factor influenced the willingness of farmers to adopt an agro-environmental practices. And most of the research that were looking at this question, until we did this research, were actually looking at existing programs. So people took people that were only part of a program and assessed to what extent they're happy with the program, etc., etc. What we did was a focus group, a survey for the community, and an in-depth interview. I'll just talk today about a focus group. We focused on 4 practices that we identified in long process that were relevant for this area. We explained about them, discussed them with the farmers, 41 farmers, explain about the EU policy, and then talk about them again, kind of under a EU policy, and see how the attitude will change in the second round of discussion. And these are the results. In general, farmers show high support in agri-environmental practices, in going to this kind of European, they like the European scheme, of course, they can get some money and can get some support. And the willingness to adopt the practice slightly increased in 2 practices, implementing field margin and reducing chemicals after we introduced the European program. It's important to note that except for habitat diversity, which they really didn't get this whole point of habitat diversity, so they don't see the point of making this. So apart from habitat diversity, which is kind of against that, all the rest were already pretty high, 4 to 5, already almost 4 or above 4, so it's quite high. What were the barriers? And I'm summarizing this focus group. So the first thing is that don't trust the government at all. And they said, if the OV program, we're going to join because they don't trust the government. They've said, no personal experience. We don't really know too much about what you're talking about. They're really afraid of losing control and afraid of breaking the norms. We have norms. For years, been taught that that's the way farming should do. We have to kill the field margin because that's the old damage come from, and we're not going to break the norms. This were the barriers. But on the other hand, they were excited about the opportunity for some support from the government. They want to improve the public image. It really reflects, and all of them has very high environmental values and they really want closer appreciation from the community, both local community, but also national community. So they really wanted this kind of program to increase their image, the image of the farming in Israel. What was interesting is that what they wanted mostly, that the policy, any policy will be flexible. So not something that's top down, will be, they didn't really want subsidies. So they thought about subsidies, some kind of a wheelchair. We said, I don't want to be in a wheelchair. But what they did want is some kind of economic safety net. Give us some seed money to start and to make sure that if it fails, somebody gonna back us up. But if it works, we are willing to go on our own. And I'll read a quote. There is no one thing that's right for everyone. And that's everyone should do. Every area, every farmer, according to their crop type, needs to learn what's right for them. And you may need to help them find what's right for them. If the state will help and encourage farmers to start this, you can put the farmer on the skateboard and then they can take it on from there. So they're actually pretty keen. And that's a very good quote of one of the farmers. But the other thing they said they really need is more knowledge. And here one of the farmers said, I don't know any program of managing margins. What we know today is destroy everything. If we develop a program where I'll go wild, let's say I sow a weed that's good for us and doesn't harm us, then we can talk. Today, it's either bad weeds comes in and do a lot of damage, or we kill everything. We choose killing everything because that's the easiest option for us. So they lack the knowledge. So we need to, as scientists, we need to provide them the knowledge, and that's what we started. And we looked at this field margin. This is a few examples of field margin you can find in the area of Harod Valley. And there's quite a lot of research that look at field margin, restoring field margin, showing that it can restore natural habitat and biodiversity, improve connectivity in different ways, ecosystem services, damage to crop, but there was nobody looked at all this holistically and also look at the impact to the farmers, kind of trying to look at the cost and benefits. And that was the part of the work of Hila Segra, who led it to the PhD, and she looked how field margin affect biodiversity, pets, natural enemies, damage to crop, and also quite a lot of things. And we look at all this also in terms of distance from the field margin, so into the field, but I'm not going to talk about it today because I don't have, unfortunately, enough time. So this is the experiment we had. So we wanted to restore field margin like it's been done in Europe. Unfortunately, we couldn't get the permission to do that because we have to use local seeds from Harod Valley. That was impossible to gain. It was too expensive. So we chose the option what the farmers did. We basically took an area of 200, 300 meters long of field margin and killed it completely. So this is what you see here. This is us killing nature. So I'm very proud of this, as you probably see. But this is a good experimental setting. We have 200 areas of, again, replicating what the farmer normally doing, 200, 300 meters, and natural vegetation, 14 sites. We had much more sites, but working with farmers is complicated. And 11 wheat, 3 tomatoes. And we sampled all this stuff, so quite a lot of stuff. We sampled yield, natural enemies, so it's a good collaborative work with lots of other scientists, pests and damage to the crop, rodents, weeds, biodiversity, and here we did in terms of butterflies. So quite a lot of measures, and we did a sampling again from the distance from the field margin into the field. Okay, that was the setting, and we basically compared the vegetation one to the one that's completely killed using the herbicide. Again, I'll take you through the results. Partly, we look at weeds. For wheat, we had higher infection of weeds in the area which was vegetated. That's what the farmers claimed, the weeds coming from the field margin, and you can see it here. The straight line here is the vegetation, and the dashed is the herbicide in distance from the field margin. And basically, throughout, we have more weeds, going down a little bit, but you have more weeds than the herbicide. So this was only true for wheat, but when you look at tomato, the pattern completely flipped, yes? We have more weeds, interestingly, in the herbicide, the areas that were sprayed. When you look at natural enemies, everything was positive. In the area that vegetation will remain, we have more natural enemies, both in wheat and both in tomato crops. And look at pest damage, we can only test it for tomato. We have less pest damage for tomato crops. Rodent, we couldn't find any significant patterns of rodents. Yield was higher only for tomato, and we didn't find any impact of yield in wheat. And biodiversity, we found small, not very strong, but significant positive trend, increase in biodiversity for field margin. So basically, if you look at all this picture together, field margin provides more benefits, both to farmers and for ecology for the two crops we studied, tomatoes and wheat, than damage. And these are a great opportunity, especially for the tomatoes. It's important here to kind of, this is a huge topic in agroecology. It's kind of pest control. I'm not going to get into it, but clearly we find that depending on which type of natural enemies, the decline into the field varies. So some natural enemies are going to go deep into the field, some are not going to go into the field. So it's a much more complicated pattern, which I cannot elaborate on now. But the question which was still interesting for us, okay, so the field margin for some crops can be good, a little bit of damage for the wheat, not really in the yield, but what's better? The field margin or the semi-natural habitat? And for that reason, we did another survey, and this time we cover much more crops, and we look at the benefits, or again, benefits of biodiversity and pest control, all around the Chorod Valley. Again, here the green lines are the protected areas and all the citrus agriculture. These are our transects all around. We sampled in 3 seasons. So along the agriculture year, birds, butterfly, plants, plant-associated arthropods, so actually with a big vacuum that suck them and then analyze them in the lab, and ground-dwelling arthropods with pit traps. Quite a lot of work, digging 10 traps per 3 seasons. It's a lot of digging. I started doing it, then I hired someone. I thought I could do it, but then it was too much. Field margin, we looked at different habitats, field margin, semi-natural habitats. So we don't have really natural habitat because it's grazing all around, so it's semi-natural habitat. We look at field wheat, tomatoes, watermelon, and all the orchards, olive, almond, and citrus, so different type of crops. And again, look at yield, inputs and outputs, profit, etc. from economic perspective. And to look at the results, and I'm not going to take you again, quick overview of the results. We compared the cultivated from the field margin. We look at the long response ratio, hit the 0 line. If it's positive, it means it's positive. If it's negative, positive means that field margin are better than the cultivated area. If it's negative, they are worse. These are the different taxonomic groups. And you see that in general, field margin function better, as you probably expect, better than the cultivated areas. And this is what you see here. In general, we find an increase of 64%. So field margin increase, diversity of species, and this is in this case is richness in 64%. When you compare field margins to semi-natural habitat, opposite trend, yes? I forgot to say this is different seasons and everything is a bit more complicated. It's varying with seasons and taxonomic group. But in general, I want to look at the general because this is the ecological effectiveness. When you compare field margin to semi-natural habitat, you find a decrease. Yes, so semi-natural habitat provide more benefit. Look at these butterflies here, not significant, but still, for butterflies in general arthropod, it wasn't so bad. And that's actually the next slide. So we find that for small species, arthropods, butterflies, it's actually field margin can sustain quite a remarkable population in communities. But when you look at birds and plants, it's too small. Like this field margin, we're talking about 6, 10 meters, sometimes 15 meters, not very wide. So they are very good for small animals, but not for larger species. For the economic, it was a bit more complicated. Had to calculate what the economic cost, and this is proportional to the amount of field margin covering each of the fields we have. And so we had to make these models and test for the relationship between each crop and the proportional field margin. We've done it for each one of those fields. Some of them were significant, some of them were positive, some of them were negative. But in general, we use this to kind of calculate the cost of sharing, which is how much impact this field margin will have on a given crop, if that is the relation. The cost can also be positive. And we can also calculate the cost of sparing, basically taking the land, taking the field, which is that's the profit in shekels per hectare. This is taking the field and converting it to natural reserve or something else, or taking into account the damage that will be resulted by the field margin. Taking all this stuff into consideration, and that's what all to this big sharing model. So this is the big model, in which one we use Pareto optimization to trying to optimize both economic cost and the reduced economic cost and increase ecological effectiveness, so cost effectiveness, calculating the way I just explained, and looking at various variables. So first of all, we want to know when should we share and spare. We compare the width of field margin, for instance. We compare the crop composition, so a lot of scenarios, different crop composition, the perimeter of the size of the field, the perimeter of the field, and all the measures of biodiversity, including abundance, diversity, so lots of ecological measures. So quite a lot of things went into the scenario modeling. And we wanted to know also which variable actually influenced the decision. So when should we spare? Let's say if you look at butterfly, should we spare, should we share? If you look at birds, etc., etc., etc. And that was our big model. And to summarize the result is our model again. And the first result that in general, and that's actually corresponds with most of the literature, sparing is better than sharing. Yes. So if you want to take a quick decision without strong consideration, spare land. So better to do this one big, wide corridor than many, many small corridors, because in general, there's a bit of an impact or some impact from the field. We look at several crops together. It's important to mention that the crops we look at cover about 80% of the land. So we cover most of the crops that are being cultivated in the area. This, of course, varies between species and indicators. So again, notice that for birds, that for butterflies, butterfly plants, butterfly arthropods, it's kind of 50-50. But when you go to plants and birds, as I said before, they need more, they don't benefit in field margin, and therefore it's much better for them to spare land than to share land. What was really interesting about this result, and this is the first paper that actually take into account the economic consideration, that the optimal strategy was almost twice as sensitive to the costs and the benefits. So what's really important is the crop composition. So what really determine whether you want to share or spare is not which taxa you're looking at, it's not, or the lesser extent which taxa you're looking at, it's not which indicator, ecological indicator, perimeter of the field. What's really important, the most important thing is the crop composition. So for different crop, you'll have a different sparing, sharing decision. I think this is very nice. I think in 15% of the scenario change because of the crop composition. Another example is the whole idea of field, the other variable important, the field margin width. Again, field margin width also, it's kind of sparing sharing. Yes, 10 compared to 20 and above. So when you look at field margin of 10%, clearly it goes towards sparing. When you increase a little bit the field margin to 20 meters, you already somewhere like 50-50. Yes, so sparing, sharing, you are kind of in between. And what altogether, I think what's really nice to see that there's no one size fits all solution. Yes. So for tomato, it's much better sparing. You probably understand that giving the previous experiment. Orchard citrus also, and then it goes further away towards sparing, and same thing with the biodiversity indicator. So I think in general, I will summarize saying that land sparing is better than land sharing. Okay. But and that economic costs are more important than ecological costs. I think really important to take into account those economic costs when planning landscape and not just focusing on ecological values. And that in this case, it is our case, maybe agricultural areas are really diverse, and therefore there's no one size fits all solution, and we need diverse solutions. So for this area, which is completely irrigated with vegetables, most probably the land sharing could be pretty useful here. But for this area, which is rain-fed with wheat, maybe, or this our result shows that you want the more land sparing approach. So it really depends on which kind of system you're working on. And so I was really excited about this because but then I kind of thought to myself, great, so this is all great. Wow, how all this is actually related to ecological corridors? Because the whole point of what we're doing is designing an ecological corridor, and we're doing what everybody else is doing, yes? So this is an ecological corridor, and we're doing what everybody else are doing. We're keep on looking at on communities, assuming that if you have communities of species, that species can move in the landscape, right? And this is completely shifted the way I was looking at things. I've been looking at communities all my life. That's what I'm mostly doing. People are also doing habitat stability, which I'm also doing. So I've been doing this all my life, and I want to do something different, start looking at animal movement. And this work together with Dr. Urs Spiegel from Tel Aviv University, who is a movement ecologist and behavior ecologist, and the PhD student Michal Hendel. We were leading this research trying to identify the factors that facilitate or impede animal movement in agricultural landscape, and actually understand how we design effective corridors. That is the new thing that gives you some preliminary result. So what we did here is very novel. We use a system called Atlas, which is only in 4 or 5 systems already built around the world. The whole idea is to do a reverse GPS thing. So tracking animals using reverse GPS. Normally, you know, animals carry the GPS on the back, GPS calculates, and you have to download the data from somehow from the bird. And it's quite a lot of things that the bird has to do, the animal has to have on the back. What we're doing here is building towers in the landscape. Okay, and then every 4 or 8 seconds, the bird sends this very, very small transmitter, send a ping. Towers look at the time difference between the the pings between the different towers. As soon as you have 3 towers, you can make triangulation and identify the location. Then the information is being sent to a server in my university, and actually I can open my phone and see exactly where the bird is located. It's very similar to GPS in terms of the location. It's really like 2 to 4 meters. So this is a huge change because the tags, unlike GPS, you can get to $1,000 or even more. The tags here much more from $1,000, no? The tag for $40. That's a tag. So we can have a massive deployment of birds, $40 per tag, very small, so you can capture really, really small bird. Talking about less today, it's even 0.4 gram. 0.4 gram, you can put tags on very, very small birds for a couple of weeks. Again, location every few seconds, like it's low energy consumption. So every 8 to 4 seconds, you get a location. And this is what we did. We built these towers all around, mostly on mobile phones. We collaborate with mobile companies and put our antennas on the mobile phone, but also some of them we had to build ourselves using solar panels and building them. And we cover an area in Israel and Jordan of about 400 square kilometers. Quite a remarkable area. And tell you that look at the remarkable data we have. We only cover 25 species, 734 individuals, 92,000, almost 93,000 tracking days, and over 500 million location of birds. So we have a huge data set. We haven't started using this data. So that's a big problem. Next problem is how can you use such a big database? But that's for the next talk. And we started working on birds because that was the easiest thing to do, but we're also working now on mammals, so gazelles that we introduced the area, and jackals that are also quite abundant there. We want to use porcupine, many other things, and our system actually works pretty good with all those birds. So we can look at stuff like max displacement, so where the bird is located, but that's home range and how far it goes from the place its nest, for instance. And these are some examples for few bird species. And I think what's interesting and what I like about it is that you see that there are trends at the distribution of max displacement, and you see that for some species like the bulbul here, there's 2 kind of population. Yes, the one that really don't move too much and the one that move much more. Yes, and it's also the case for the collard dove and slightly for the jay and for the woodpecker. So there's kind of different type of movement activities. We can also use analysis like step selection function. This again, the bulbul, which is going to be our star from now on, because it's easy to catch. And when we look at each step that the individual make, where they go, they have different opportunities where they go, and we can look and see that they really avoid arable field, right? So they really avoid this arable field, and look at also this, they really avoid cover plantation. Because in general, they're far away. It's not significant, but they're avoiding them. And I'm sure with the data we have now added, it will be even more significant. What we can also do, we can start, because we have such a high resolution data, we can start separating between different types of movement. Local movement, which is like really locally moving in one area. We can look at non-directional movement, like a living walk around the field, probably foraging, and we can separate directional movement, where they're actually flying straight from one side to another, and we can analyze. And we started doing this, analyzing different types of movement. And these movements are really important from the idea of corridor, because in corridor, you might want to just look at those movements, just on the blue movement, not necessarily want to look at the non-directional or the local movements. We can separate those movements and start exploring those more specifically. This is all these opportunities that we have because of this high resolution. We have every 4 seconds, every 8 seconds a location. And I think this really proved the point even more. They have this bulbul that nest here. That's the nesting ground of these species, these orchards around here. And this is the village or kibbutz, where it's actually forage. And you can notice very clearly that the bulbul always go along the field margin. So they don't fly. They almost never get into the arable area, the field. They always fly around the field margin. We're talking about within their home range. So this is the area of 1 or 2 kilometer flights that they fly every day. You know, they're going back to work and they're really clearly avoiding the field. Now, if most people that did telemetry so far, they had a point here, a point here, a point here, and probably what to do is something like this. We can do with the 4 seconds, we can really know almost every second where the bird is, and we can see the differences. Similar pattern we'll find for woodpeckers, again, avoiding field margins and staying along the, avoiding fields, and staying along the field margins. But that's not all the species, because some species like the greenfinch, see, they just fly all around. Yes, they're flocking together and they do whatever they want and they fly all around. What we're now doing today is actually finished last week. If you wanted to test this question experimentally. And we did a relocation experiment. We took the bird from the breeding site move them about 3.5 kilometers, which is still within their home range, so the area they know and they feel comfortable with to fly back, and put them in an area there is a clear corridor back. There is no corridor, it's mostly field and some stepping stones, and an option for a field, also a road, looking at the effect of a road. We have 75, now we have 94. 94 bulbuls that was done this experiment. Again, telemetry, you can know whether they return or not. That's what people have done so far. But we can know exactly how they return, and that's the last movie for today. And here you can see, this is the bird, that's the nesting site, starting to fly. They really like the rural settlements. Gather something, going to the wrong way. Again, flying, looks at most of the flight, not all of them, most of the flights actually along the field now. Yes, so they really use this habitat. The same habitat that I told you before that are not very important for birds. Yes, so in terms of habitat, we didn't find that they're that important. This is the return rate. So return rates are faster. Duration is faster for natural areas compared to roads and arable. Distance moves shorter compared to roads and arable. And also we saw, as expected, this kind of returning all over again and again, so that avoiding the straight line with this amount of arable field is actually avoiding arable field. They prefer natural vegetation, avoid cover plantation. They like the build or the rural area. It's not really build, it's more rural, and avoid water bodies. So this kind of different pattern we can do with this very high resolution data. So if I like just to summarize this and the whole talk in general, so narrow uncultivated field margin, they're not really good in sustaining a lot of birds or bird communities, but it can be pretty important for birds movement, at least in the local scale. And I think it also shows that it's important to look at behaviors and not just at presence, absence, or communities. Look at process-like behavior. And so we're just at the beginning. This allows us to really explore behavior on a community scale. You can have so many species, so many individuals, can really look at community scale and identify again the factors that facilitate the bed we already have. And for some species, the result that they are actually blocked by arable land. It's actually, I think, pretty impressive. I'd like to summarize all the talk all together that I showed you today, or I showed you today. So I think it's important to start by stating that I don't think that multifunctional landscape can replace protected areas. And they will never be able to do that, but they are a great tool to complement them. Yeah. So if you can take a land and make it protected or restored it, that's really, really great. But multifunctional cannot really replace protected areas. And again, there is no one size fit all. It's really context dependent. I think that also was also a message in the last talk. It's context dependent, and we need to really understand what the best solution for your place. And I think if you're talking about designing multifunctional landscape, we're talking about seeking for opportunities. And in that regard, we can have two types of solutions, two types of opportunities. We have the low-hanging fruit, where the farmers or landowners, somebody doing something really bad, like this case in this extensive, they're hurting themselves, or like this also the tomato, they're actually killing the field margin, that's reducing their yield and increasing the damage in the field. This is the lose-lose situation. In that regard, we need to show them they're doing something wrong and they can benefit more from restoring a field margin. The other thing, there's also opportunities for win-win. Again, the farmers can earn much more money if they move for organic, some sort of organic farming. And this is supposed to be pretty easy. What we need is knowledge and some ideas about behavioral change. How can we persuade them, show them the evidence, and change them? It's not just showing the evidence, actually move behavioral change. On the other hand, we have these low high fruits, basically in places which are high ecologically important. We need financial support. The government needs to put the money in the pocket and support the farmers and help them to do better. This is in case of the traditional farming or buying land for conservation. And I think it's a mixture, and we need to be really careful about where we're doing, where we are investing, what we're investing, because I said before, it's not going to work similarly everywhere. That's it. So thank you for all my collaborators. Thank you for listening. And I'm happy for questions.
Thanks very much for that. Very engaging. We're all getting to the top there. I think it's really nice to illustrate the importance of interdisciplinary research. And I was wondering, just two small questions. the control for the ecological aspect when you're comparing social to economic, those three. I'm not sure if I caught what that was. And the other one, I was just wondering.
The control for the olives, first one, or
the olives one.
Yeah. So the social stuff we didn't ask about didn't ask for the control. We just looked within for the ecological.
Ecological one. I know there was no control for social, but
so the ecological was the park, mostly oak tree, park forest oak tree. So kind of similar, but not 100% that, because in some places we couldn't find nearby a control site because everything's already destroyed. So we took like a pine forest, which is a planted pine forest. So ideally it would be an oak, kind of oak park forest. And the second question?
Yeah, the 0.4 gram tag. Just wondering the battery life on that, because that's pretty impressive for a tag.
Who?
The battery life, how long could it last?
The 4-point tag, you can, again, with 4 seconds, it's something like between a week and 7 and 10 days.
All right.
But the problem with this, I think that to get better problem with this system, and again, it's local. So let's say bird migration, you cannot study with this because it's very, very local. And the thing, the investment here is to build the towers, yes. So you need to, each tower costs about something like 7,000 Australian dollars, not that much, but you need also to build them, find the collaboration. So it's that's the investment. Then tags themselves are really cheap, even cheaper than $40. Very small. Yeah.
I'm curious, you were mentioning that the organic solution is a win-win for farmers, but a lot of farmers are really stubborn and they don't want to change because of habit and culture and such. Did you ever talk to them or communicate with them the benefits of shifting? And when you did and showed the data and such, and when you did, what were their reactions? Basically, did you manage to get them to change their opinion by showing data or this?
I like to make, I try to simplify a bit in my talk, not to get into more, but there is a problem with organic. It's a kind of almost a religion. I don't know if you've been looking at organic farming, there's so many rules you have to do. You just show a farmer all these rules you have to do to become organic, they would like, they freak out. So I talk quite a lot with farmers about this organic. Not all of them are really, at least to my opinion, relevant for biodiversity and ecological conservation. Many of them are mostly relevant for for use of herbicide and pesticide. I've talked to kind of farmers, and that's the problem there. Yes, they really don't want to do all the bureaucracy of understanding, and it's going to take them time to clean the landscape, like 2-3 years. So there's a lot of process there into it. And other farmers were really surprised. They didn't believe that didn't believe that the organic farming can provide so much yield like a normal farm. They really didn't believe us. They still don't believe us. Yes, they still don't believe us. What happened with farmers in organic, at least in some of the area we are working on, is that the farmers understand that pesticides and herbicides are bad for them, and they would like to get when the crops are really close to the homes, they do organic around their homes. So they don't care about the landscape, but around their home, around the kids, they want everything to be neat and clean and safe. So they're starting from there, and normally what happens there that they see that it doesn't, like you get similar yield in organic, it's not that bad, yes. And then they move. So they need another type of incentive. I think I simplified it a bit when I mentioned it. Just telling them is not enough. They need support, guidance, and again, so the government need to invest, but not in giving them money, actually investing in helping them make them move in the shift.
Yeah. I had a very quick follow-up on that yield question in organic. The yield in organic was higher, right, than the non-organic, substantially higher. Yes. Have you got any idea why that is?
I think all the organic farmers are very serious people. They collect data really well, so they're really, so it's a different culture of agriculture. Or the farmers are, yeah.
So they're just better farmers.
I think they're better farmers, yes. So that's my feeling, and they're doing very well. They know I didn't interview them, but I met a few of them and I talked to them. They're really well connected, know very well all the different pests. The other farmers just just put airplanes of pesticide all over. They know every pest and they adapt, and they really know it. I think when you're really that dedicated into your land and to cultivating your land, you're getting better. I think that's my feeling. Yeah.
I'm just thinking about this organic yield being higher. How do you reconcile that with the sort of sharing trade-off? Presumably the assumption is in that debate is that sort of the organic, more sparing type approach has a lower yield per unit area.
Yeah, so
it seems contradictory. So there is, so if it's you've got high yields in organic, there is no trade-off, right?
Exactly. So this is this kind of the assumption, and in the model that we did, the big 30 models actually taking into account. But there's a lot of organic fields, so this kind of it's already been accounted in the model. Okay, there is some inputs. Yeah, so it's not. This is what we showed here for the olives. It was very strong. For the rest, the organic wasn't. The yield wasn't actually. Yeah, it wasn't higher or lower. It wasn't really lower, higher, maybe slightly lower. So altogether, we take this into account. It's kind of. Yeah, it contradicts the spherical sharing approach. At least for the olives, clearly contradicts spherical sharing, but for the whole system that we looked at in the Harod Valley, it wasn't strong. The effect wasn't strong enough to change the shift, because at the end of the day, 62% of the scenarios we got, including organic stuff, we still got preferred unspherical and sharing. The question is whether we can make method or whether the olive is just an opportunity, like a special opportunity, unlike other crops, whether we can do organic, which is as good yield as the non-organic. This is the so tomatoes, for instance, to study, the organic was not as good in the yield. It's really context dependent, and this is I think the challenge. So still, the model shows that even though that's not as good in the non-organic. Yes.
We found any links between like movement strategies and say conservation status of birds or type of birds, such that like are there groups that are more affected by these margins that are going to be more affected if they lose the margins or lose other habitat areas?
In terms of instead of endangered,
Yeah, like
so no. So again, this is talking about the last. I don't. To be honest, the big survey we did, it was really bad for birds. So this kind of field margin, we're talking about 10 meter long, wide, and mostly rural species. So not too many birds nest there, or just mostly, just fly around. But when you look at the movement patterns, so we haven't looked. So we don't. To be honest, we haven't really tried to look at rare endangered species because we're not authorized to catch them. I think that's the first problem we have. So we didn't touch any one of those important species. I'm trying to think if we had out of those 20 different species or more. No, so we haven't looked at it yet. So it's something we can't do at the moment.
Maybe an allied question to that. Do you have any sense of how birds might travel through a natural landscape? For example, inside a protected area? Because I suppose your underlying assumption is, well, they'll just go straight, right? Because it's all natural habitat. But I wonder how heterogeneous even a sort of natural habitat might be from an animal's point of view.
So we haven't looked at it at all. And the problem is this is a great point, right? I think it's a good point to look, and we have natural or semi-natural large patches in our area and protected areas also. So our system covers quite a lot of natural areas, and we can look at this. We haven't tried to look at it. The problem is to kind of how can we understand first of all how they move. So we have this, we started doing this one I just showed here. So we can look at this figure here. This is all natural patch. Okay, all this is natural patch, and we know that they're quite wide. So this is it's not a kilometer, but 700 meters, so quite a nice patch. So we can look how they move here. This is a kestrel, so it's relatively easy, but it's really interesting to look at smaller birds, how they move in this natural. So we haven't done it before. We can do that. I think the challenge will be to relate it. So how they move, we can characterize, but to relate it to features of the landscape, whether let's say individual trees, and this completely is doable. But then we need to find a way to work on characterizing the landscape and then relating the behavior to the landscape. This is going to be it's a very interesting direction which we haven't tried yet.
And I think there's, so I don't want to talk too much, but there's massive applied importance of this work, right? Because developers always say, well, we can take out this patch, birds have wings and they can fly, right? But this shows that they don't, that's not how they work. That completely changes the game.
And this is why, I think I agree completely. That's why this kind of looking at animal movement and general processes is so important, because we kind of said that field margin are not important for birds. Yes, no birds, no composition, no diversity. Suddenly we find that they're really important, not for all birds, yes, I said before, but for at least 10 out of the species we studied really fly along the field margin. And this is, it's important to say, like I presented to the president of the Technion, my university, and he said, yeah, but he's a pilot, a helicopter pilot. And he said, yeah, but of course, they they use it for navigation. No, this is the area, this is the home range. Yes, they don't need to navigate in this area. So they actually choose to fly here. It's important for them to fly across this. What we want to do now, the next step of this project, just got finance for this, is to restore habitat. To restore habitat and see how this influences their movement. Yes, to kind of do habitat restoration and look at it. And it will be interesting, really interesting about it. We still have time for one more question or not?
Yeah. So at the end of the day, individual birds and animals have a certain amount of energy to spend. They have to prioritize what behaviors they'll take, and traveling is one of them. So I guess, yes, they are adapting potentially their movement ecology to differences in landscapes, but I think the question is whether there are costs associated with that. Because it might be not costly to them at all, right? Just saying, this is how much energy I have, I'll negotiate my landscape to maximize my fitness. So I think the question is, does it relate to cost to the animal? That's what's difficult.
I completely agree, but imagine that at the moment, we don't know. The answer is, of course, to your question, I don't know at the moment, but imagine we can make an experiment and kill all the field mountain one. Then maybe they will have to forage because they don't have a pathway, they don't have a connection to go to this settlement, yes? And clearly there is quite a lot of food in the settlement, a lot of ornamental trees and part of the food. So I don't know what the cost. This looks like not such a big cost, yes? It's I think like a 2 kilometers flight. So it's not such a big cost to fly a little bit around, and the risk is probably big in the middle of the field. So yeah, look at the cost note, but the question, what happens if we do what Rich said, we're gonna just build, like intensify everything, leave nothing, and maybe they won't survive because they need resources. Here is from settlement, but another bird from something else. And I hope that there's kind of restoration. What I hope to find is if we restore habitat here, we'll finally see that suddenly this bird is preferring to go, maybe there's no field margin here, prefer to go to this habitat, which hasn't been used because it was actually not connected. That's the opposite of what we're thinking to an extent.
Oh, it's interesting because it definitely might be restricting it, constraining it to in space and time. What would be interesting with the data that you have is to look at density of cohabitation, density of utilization of those corridors, because then you can think about transmission of disease and you can think about some of the costs associated with that. Because if you're restricting movement, a lot of bird and animals deal with the coexistence with conspecific by either spatially segregating, spatially temporally segregating. And what you're showing here is potentially changes in landscape structure takes that away from them. They might be utilizing these corridors to high density. And it would be really interesting because you do have the data is to look at the number of instances where you get high density of utilization potential loss. Disease transmission spill over both into humans and agricultural livestock.
So my colleague I'm working on this with Pigeon. I should say like this, and it's interesting. We can talk about it.
Yeah, that's a conversation that should definitely continue and take shape over the next few weeks. Yeah, sounds good. Listen, thanks everyone for coming. Thanks, Asaf, for a wonderful presentation. You're extremely high energy and innovative research, and it really is great to hear all the work you're doing. You said something I thought you'd never say in this talk. I thought I could do it, but then it was too much in relation to digging holes. I never thought you would say that about anything that you ever approached. So thanks for your energy. Thanks for your work, and it's been great listening to you.
Thank you.